campus. It's a beautiful place. Thank you very much for organizing this and inviting me, giving me the opportunity to share our technology and thoughts about this industry to the students and the professionals in Southern California. So I'm Haoyuan Li, and people also call me Try, and I'm the CEO of this company, ALLUXIO, and we're the company behind this open source project, which is also called ALLUXIO, which came out from UC Berkeley AMPLA. I was a co-creator of the project while I was doing my PhD at UC Berkeley. So before talking about what is ALLUXIO, I want to explain and talk about what's the industry, how the ecosystem in the industry look like in the big data ecosystem. So around 10 years ago, companies like Google published a paper like MapReduce and MapReduce and GFS, which are foundations of the big data analytical industry. So then, after that, companies like Yahoo, they started to develop these open source systems like MapReduce and HDFS. They are very simple components in starting the ecosystem. So along the way, along the past 1 decade, you see that different companies and organizations, they started to gather more data, store more data, as well as trying to extract values through sophisticated solutions to help their business to be more efficient. So then, because of this, you can see that the ecosystem has evolved significantly over the past 10 years. And we look at this basically through two perspectives. On one layer, we see this is basically the compute layer, which help you use different algorithms, different solutions to extract values from the data. And the other layer we're seeing is the storage layer. And for the storage layer, along the way from HDFS, because of the more data, and it's attracted many storage vendors going into this as well. And you can see nowadays, besides the HDFS, originally we have public cloud storage like Amazon S3, like Microsoft, Google Cloud Storage, and many private cloud storage like Swift, and many storage from traditional storage vendors like EMC, like NetApp, like Huawei. And then, due to advancement of the ecosystem, people have more ways of dealing with data. However, there are more issues as well. And the very first issue you can see, and the ecosystem became very messy. And therefore, to integrate more solutions into the ecosystem is harder and harder, and it's not efficient. And on top of that, many of these big data storage systems were not built for this big data workload. Therefore, the performance is very bad as well. So then, to solve this issue, we developed a system called ALLUXIO, and we stay in the middle between the upper layer computation frameworks as well as the lower layer storage systems. And then, what we do is that we virtualize the data from different storage systems and expose a unified API with a global namespace to the upper layer ecosystem. And the benefit is that we enable different applications to access and interact with the data from different storage systems at memory speed. So that's where we are, and why we created this system called ALLUXIO. And then, to be a little bit more concrete, ALLUXIO is a software, and this is how the architecture would look like. Without ALLUXIO, you have applications on top, and you have storage at the bottom, and they are connected through network. And with ALLUXIO, what we do is that we co-locate ourselves as a software with different applications, and then we connect the applications with data. That's the architecture figure. Okay, so another besides the ecosystem trend and the motivation for developing this software as well as this project, we also leverage other trends from industry. And one trend is about hardware. As you can see from the figures, we look at the hardware trend for both memory as well as HDD, hard disk. And what we can see that is that the memory performance is growing exponentially every year. On the other side, the disk performance grows very slowly. And in the meantime, another good news is that along with the performance improvement for the memory, the price is dropping by half every 18 months. And because of this, you can see at the bottom figure, you can see that at the beginning of 2000, the firms from Wall Street started to leverage DRAM technology aggressively. And then after that, around 2010, the big internet companies like Google, Baidu, started to investigate and leverage this technology. And then after that, around 5 years, like now, this in-memory computing is coming to the mainstream. One example is Spark technology, also came out from Amplat, which is an in-memory computation framework. And similar to Spark, serve the in-memory solution for the compute layer, and we are serving the solution between the compute and the storage. So that we also leverage this trend and develop the memory-centric architecture to best leverage the in-memory technology and provide the best performance. We have several cases we can show in the later slides. And then, if you look at what is ALLUXIO, where memory speed, virtual distributed storage, memory speed means that we have a memory speed access to data. Virtual means we virtualize the data. We virtualize the data from different storage and present a unified API and global view to the upper layer. And distributed, we have a scale-out architecture. It means that you can use ALLUXIO with 5 nodes, 50 nodes, and 5,000 nodes, and they all run fine with a linear scale-up. And then it's the storage. It has a file system API as a major API nowadays, and it's a software-only solution. And then, if we look at the benefits to the users, it will be the first benefit will be the unification. Be much easier for the users to have a global view of the data. This is very important for a lot of enterprise companies, for any organizations. If you want to access more data to generate a better insight for your institution, for your business. And then the second benefit is about performance. And we significantly improve performance compared with the previous architecture. And we have several results we can show in the later slides. And the third one is the flexibility. With using ALLUXIO, it makes you much easier to use new technology, both in the upper layer and the lower layer. If you have a new one, you can just simply make it integrated with ALLUXIO, and that will plug into the whole ecosystem. And the last one here is the cost. So with ALLUXIO, we make the separation of compute and storage efficient. And in this way, you can grow your application power as well as storage capacity in your organization independently. And that will decrease your cost, your spending on the infrastructure. Okay, so after making a very high-level overview of ALLUXIO, and I want to talk a little bit about several use cases we have seen in the different companies. And the first use case is about acceleration, the I/O to the remote storage. And so a lot of enterprise now, they are going to the route of decoupling the compute and storage. And we have benefits listed in this slide. For example, like one benefit is about the cost I just mentioned. You can decrease the cost, and also it increases the manageability of your environment. And but the issue came with new architecture is that the access to the data is slow. And the ALLUXIO came into the picture to accelerate this data access part. And this is the architecture without ALLUXIO. You can see, like you have frameworks like Spark, they will access the storage through network, and this will be slow. And this is the architecture without ALLUXIO. And with ALLUXIO, you see ALLUXIO in the middle. And what we can do is that after the first access of data, ALLUXIO will be able to access data from ALLUXIO space. Therefore, which is closer to the computation. Therefore, it's much more efficient and faster. And for this particular use case, see we have a white paper you can download online. There's a production use case from internet client Baidu. They run Spark SQL on top of ALLUXIO, and they use ALLUXIO to access their Baidu file system, which is joint store. And they have been using this deployment for more than a year with more than 200 nodes. And ALLUXIO is managing more than 2 petabytes of space. And in their workload, they have seen 5 times to 30 times performance improvement. And this particular system help their business analysts as well as product managers to get better and faster insights from their users to better develop their product to serve their customers. This use case is the same use case I mentioned earlier, that architecture. And then the second case I would like to mention is about sharing data between different applications. And when you work in a company and you want to derive insights from your data, normally you have to have a very complex, comprehensive data processing pipeline. And then without ALLUXIO, to share this data between different applications in this pipeline, you have to go through external storage systems like HDFS, like MZ3, like EMC, ECS. And this data sharing process is very slow and inefficient. And with ALLUXIO, what we want to do is to significantly improve the performance in this case. For example, you see this case, you have a giant storage at the bottom, and you have 3 applications on top. And in order for them to process the data, you see that they are slowly read and write data and interact with this giant storage to get a job done, and finally get a result. And then with ALLUXIO sits in the middle, and you see that the first job when you read the data is still sometimes from remote storage. However, after that, this whole process will become much more efficient because all the interaction only needs to happen between the applications with ALLUXIO, which is close or correlated with the applications. And this whole process will become much more efficient. And we have another public case, public user about this case. This is from a leading bank from Europe, Barclays Bank. And what they do is that they run Spark on top of ALLUXIO, And under ALLUXIO is actually a data warehouse. And in their deployment, it's 1 terabyte of storage, and they use ALLUXIO for memory only. And and also in this use case, their analysts found they could decrease the whole pipeline from hours to seconds. This is very significant. So previously, when the analyst type a query, they can go to chat or just grab a coffee somewhere, and their whole job will be several queries. And now with this new infrastructure, new technology, they can get much more done with the same time or with the less time. And then use this technology to derive better model, risk model for their bank to get either more money or save the potential loss from the fraud for the financial industry. And this is the second case we'd like to mention today. And the third one is that ALLUXIO helps you transparently manage the data from different storage systems. In the meantime, it enables you to have different applications to interact with the same storage pool at the same time as well at a high speed. And for this particular case, this is the architecture with ALLUXIO. And previously, it's very simple, just one type of application on top of ALLUXIO with one type of storage systems. And now, what we can enable is that you can add more storage, as well as you can add more compute as well on top. So this technology needs to be improved. You can see you have a very flexible architecture and to the customer, and this new architecture is much easier to use and much more easier to maintain as well. And for this particular architecture, we have another case from Qunar, which is China's Expedia. This is a Nasdaq-listed company with a market cap of 5 billion. And they run 2 type of frameworks on top of ALLUXIO, which is Spark and Flink, to do real-time machine learning to serve the ads you have to see on Qunar's website. On the other side, they have storage like HDFS, like SAP, managed by ALLUXIO as well. And in their deployment, they have hundreds of nodes, and they have average of 15 times performance improvement, and with a peak of 300 times performance improvement for Qunar's case. And in this case, they also use ALLUXIO to manage non-memory. They manage all the memory and HDD in their compute nodes, in their compute cluster. Okay, so in this slide, we are the company behind this ALLUXIO open source system. Originally, when we started from Berkeley, it's called Tachyon. And Berkeley Empire is the same place where Apache Spark and Apache Mesos came from. And we have been open sourcing ourselves for the software for around 3 years. Over the past 3 years, we have been the fastest growing open source project in the big data ecosystem. And you can see with these 3 years, we have more than 300 contributors globally from more than 100 organizations. And here, I would like to welcome anyone in the audience to join the community as well, to contribute and develop a new technology, the cutting-edge technology, as well as to use the project, the system, provide more feedback to the community as well. It will be a fun experience. And in this community, besides our company, we also have the leading IT companies from the industry, like IBM, like Intel, Red Hat, Google, Alibaba, Baidu, all these IT giants, to joint force push this technology further advanced to be better used in the industry. And then, in the end, we'd like to talk a little bit about our company, and that's me. Besides me, that's our VP of products. She has been successfully done 2 startups before, acquired by AMD and Dell. And in our team, we have PhDs from Berkeley, CMU, Stanford, and many top universities, as well as people who worked in related projects in the companies like Google, like Uber, Yahoo. And we also have the top 9 contributors in the community. And the company is founded by a venture capital Andreessen. If you are interested in full-time developing this, you are welcome to contact us. And in the end, I would like to thank you all. And here's our contact information, our Twitter, as well as our website. Thank you very much.